Good morning or good afternoon, fourth grade friends. Today is February the 9th. It is Tuesday, and we are ready to begin our number corner. I hope that you're feeling well today and that you are ready to participate because we are going to be talking mostly about angles. So I want to refresh your memory about some of the vocabulary terms that we reviewed earlier this month. When we have an angle that's really small, remember we talked about it being so cute? What do we call that angle? Yes, it's an acute angle. What about if it's exactly 90 degrees? A right angle. And how about if it is bigger than 90 degrees? Right, it's an obtuse angle. So as we talk about angles today, I want you to be thinking about those different terms because when we make observations about these angles, those are the vocabulary terms that I'm going to be expecting to hear. And those are the terms that I want you to know and understand. Let's look at today's calendar marker. It is the 9th. And we have a straight line. And it looks, actually it's not a straight line. What do we call that when we have one line going in a direction forever and then an endpoint? Yeah, we call it a ray, so it looks like a ray. Right. Well, now that we've seen our calendar grid, let's update our calendar collector. And you know, for this month, we are collecting angles. And so I am going to spin for today. So far we have 106 degrees, and it looks like we're adding another 15 degrees. So what is 106 plus 15? Did you say 121? If you did, you are absolutely correct. So 121 would be about right here. And remember, when we're talking about angles, definitely when we're measuring, or in order to measure with what we call a protractor, we would need to extend the line sometimes. And so when we extend the line, we need a straight edge to make sure that line is straight and it's going to reach the exact angle that we're talking about. So we are adding 15 degrees, and so we now have 121 degrees. Now, using some of those terms I said to you earlier, what can you say about 121 degrees? What would you say about it? What kind of angle is it? Yeah, it is an obtuse angle. So let's fill that in on our collector chart. So today we spun. Today is the 6th day of number corner for January, and we spun 15 degrees, which means that is 15 1-degree angles. Okay? Now understand what 1-degree angles means, right? When we go around our circle, all these little tiny little tick marks in between our 10s represent our 1s. So when we spin 15, we have to count 15 of those little tick marks. And now we have 121 degrees. So let's add some observations to this recording sheet. What do we know about an angle that's 30 degrees? Right, it's an acute angle. What else do we know? Do you guys remember us talking about fractional parts of a circle? So when we think about 30 degrees, how many 30-degree sections are there in a full rotation? Let's count them. So this would be 1, this will be 2, 30 to 60 is 2, 60 to 90 is 3. So there are 3 30s in each fourth. Okay, so that'll be 3, 6, 9. There are 12 30-degree angle sections in a full rotation, which means 30 degrees is, that's where we got 1/12 of a rotation. So I'm going to also add that to our observation because we had a perfect 1/12 of a full rotation. Good? All right. Well, what about, let's go to 46 degrees because 31 degrees is really close to 30 degrees. So we know it's still acute and it's slightly bigger than 1/12. Ever so slightly, just very little. But we could write it as a fraction. How many total degrees are in one full spin? Look right here. An angle that turns through 1/360th of a circle is called a 1-degree angle. So if we have 31 of those 1-degree angles, it means we have 31 360ths of a circle. Got it? Okay. So 46. 46 is really close to what? What else do we label here? Yeah, 45. 46 is close to 45, and we know that 45 was 1/8 because it's half a 90. So then I have two 45-degree angles here, 2 here, 2 here, 2 here. So 8 total in a full rotation, which means 46 degrees is still an acute angle, and it is a little bigger than 1/8 of a rotation. Y'all agree? Yeah. So we could even put that as, instead of 1/8 or bigger than 1/8, we can be really specific and say 46 over 360. Right? Okay. Now, what happens when we get to 106 degrees? What kind of angle do we now have? Yeah, it's now an obtuse angle. And an obtuse angle is anything greater than, you got it, greater than 90 degrees. So this is an obtuse angle, this is an obtuse angle, and if we want it, we could write the fractional piece of the circle. Okay, so you have a workbook page that we are going to work through completing at least part of it together, and the other part we're not going to be able to do because of being virtual, and I'm not sure if you guys have protractors, and we really haven't practiced using the protractors, but we'll talk a little bit about it. Okay, so an entire rotation is equal to 360 degrees, and I am on page 55. So if you want to find that page in your workbook, that would be awesome. Okay, so you can estimate an angle's measure by thinking about a fraction of a full rotation it is, which we kind of got a jump start on by doing that with our collector. So in the pictures below, each angle is shown in a circle, and the arc is drawn to show what part of the circle corresponds to the angle, kind of like we do for our collector. So now let's look at number 1, which is going to be our main focus for today. It says for each angle, determine what fraction of the circle or full rotation it is, and then write the angle measure in degrees. So go ahead and try part A independently. And if you need to pause this video to do so, go right ahead. Right, did you think about it? So what fraction of a full rotation is it? How many sections do we see here? 4 sections, and we're talking about one specific section, so that is 1/4. Did you get 1/4? Awesome. So it's 1/4 of a full rotation. And what do we know about 1/4? If I were to look back at my circle, here's 1/4. How many degrees is that? Yeah, it's 90 degrees. I'm going to write degrees out because I have not found, well, I guess I could make a little tiny degree symbol. So here's my 90 degrees. And that really matches closely with what we have talked about for our collector. How about for B? How many sections? 6 sections. And so this is representing 1/6 of a full rotation. Well, I wonder what degree that would be. Let's check it out. Let's think. 1/6 means I'm taking 360 degrees and I am dividing it into 6 sections. So 360 divided by 6. What do I know is going to be more than? It's going to be more than 10 for sure, because 6 times 10 is 60. It's going to be more than, we know it's going to be more than 45, because 45 is 1/8, and we're talking about 1/6, which is a bigger sliver. So if we know our properties of 10, what times 6 would give us 36? 6 times 6 is 36, so that means 6 times 60 is 360. So when I'm talking about 1/6, I'm talking about 60 degrees. Let's check that out. Here's 160 degrees. Here's 260 degrees. So 180 would be 3. So we have 3 between 0 and 180, which means we have 3 on the other side. So that works out perfectly. So it is 60 degrees. Thank you for thinking through that one with me. Miss Trammell had to think about it herself. All right, last one, C. What fraction of a rotation is this one? Oh, we know this, right? Yeah, it's 1/12. And 1/12, just to point out some things about fractions, 1/12 is actually half of the size of a 6. See, look. Here would be my 6. I were to split this in 6 groups. Here it is. Do you see that? So 1/12 is half of a 6. So half of a 6 is a 12. So half of 60 degrees is 30 degrees. So this is a 30-degree angle. And we knew that because we kind of talked about that already, right? Awesome. So the second part requires you to use a protractor to measure. And it's really hard for me to show you how to use a protractor virtually. So we're actually not going to do this part of the worksheet. But I will say, when you're measuring angles, you do have to pay attention to the arc. So in this case, we're not measuring here, this side. We're measuring the arc that's highlighted for us. And so if we were looking at that, we could say that we know the angle is greater than 90 degrees, which means it's what type of angle? Yeah, it's a obtuse angle. And if we really want to be fancy, we could estimate that maybe this is 90 and this looks like it's about, maybe about 45, less than 60, but more than 30. So 90 plus 45 could be 135 degrees. So maybe it's 135 degrees. So we're not going to actually measure it, but we can write an estimate. So here's 135 degrees for my estimate. The fraction, well, we know it's greater than 1/4. And if it's 45 degrees, which is 1/8, we got 1/4 plus 1/8 would be 3/8. So maybe it's 3/8. And I so wish there were a protractor here for me to check it, but there's not, so that's okay. All right, let's estimate the next one. We know it's less than, measuring this piece right here, that's highlighted. We know it's less than 90 degrees. So if I would have had to guess, I would say maybe 80 degrees or 85 degrees. That would be my estimate. I'm going to go with 85. What might you say? Okay, so if it's 85 degrees, it means it's really, really close to 1/4. So I might just say it's less than 1/4, because it is. It's just a little less than 1/4. But not quite a 1/5. Maybe more than a 1/5. All right, now this is a big one. We know it's an obtuse angle. And maybe for this one, since it's so close to a full rotation, we compare it to what we know about this section. We know this section is a 1/4. And we know this is 90 degrees. And then there's a little sliver, which may be 95, which leaves us with how many degrees here? What would this degree be? We would have 90 plus another 90, or we know, or we should maybe remember that this is 180 degrees, a half of a full rotation, plus another 80, 85. What would you get? Yeah, so maybe like 260, 265. That's our estimate. And that's all that we're able to do on this page because we don't have protractors. If I were to estimate my fractional piece, I know that it's less than 3/4. It's more than 2/4. It's even more than, if this is a 6, or maybe it's 5/6. Maybe that would be a good estimate. You see where I get 5/6 from? If I were to scroll up here, have 1, 2, 3, 4, 5, 6, it would look like this. We'd have just a little bit left, so I would say maybe less than 5/6. Just going back and looking at it. All right. Thank you guys for participating with me today. I hope you have a great rest of your day, and I'll see you tomorrow. Bye-bye.